evening, guten Abend. Thanks everyone for joining. I know this is the last unfortunate slot between the drinks that I have to fill here. I am not going to use the speakers here because there were some lag problems throughout the day, so I tried to talk loud. But as this room is not super packed anyway, you can always also feel free to come a little closer in case you don't hear me well. Or if you don't understand something, just let me know and I'll be happy to repeat it. So yeah, I'm also going to talk a little bit about the topic of observability. But for those who have been here in Gray's excellent talk before, it's a bit a different pitch. The title says from K8s to open telemetry, and there's a bit of a story to that, because this talk was initially not accepted for JCon. I got the feedback that they have so many talks on the topic of open telemetry already. And I said, well, this talk, I mean, from K8s to open telemetry is about to talk about a range of tools to do observability and not about just those two ones. So when they had a cancellation, they asked me to rephrase my title and my abstract a little bit and make clear this is not like an only telemetry and tracing talk, but more like around the options. And this is kind of how I got into the conference at a later stage. Now, a few words about myself. That's me. My name is Matthias. I work for a company called Novatech. These are my social handles. I use them fairly frequently, so feel free to connect whenever you like. So in my daily job, I actually work with a wide range of technologies a lot. So I'm a consultant. I help people. I have help clients on their cloud native journey. There's a lot of technologies involved in order to get there. So this is what I'm doing fairly often. No, it is actually K8s. Is that right? Okay, I mean, thanks for making this clear. So K8s is an abbreviation for Kubernetes in general, and K9s is one of the tools to look into Kubernetes. So then the schedule is actually wrong. Thanks for indicating that. So this is not from Kubernetes to OpenTelemetry. It really should say from K9s to OpenTelemetry. Thanks for pointing that out. All right. So yeah, I'm gonna make the intro short then. The other thing that I do next to my job at Novatech is also I'm teaching at 2 universities in the area of distributed systems. So I try to do distributed systems with modern technologies, microservice workloads, containers. Sometimes go even deeper into the topic of Kubernetes, and that's what I'm doing in my job as well. I teach that technologies in various classes and try to bring people forward with that. All right, this is a link to my slide deck in case you want to download it. You can decide later if you like it. I'm going to have that link at the end of the slide deck again, so you don't need to do that now, but if you want to follow along, you just can. Now, yeah, these are the things. So this is now K8s, Kubernetes. These are the 3 topics of this talk today. So who in the room is using Kubernetes? Good. And this is JCon, so I probably don't have to ask who is using Java. I guess we're there. So yeah, in a nutshell, why would you want to do some things like observability and introspection of your environment? Kubernetes, for those who have experienced it, it's not an easy thing, especially not in the beginning. And to figure out what is going in and around your cluster can be quite a challenging thing. So I want to introduce to a couple of approaches and aspects of how to observe things in Kubernetes about your workloads, about your clusters and all that. So what makes this kind of challenging is that it is not only about the workloads. So you need, in order to work with Kubernetes, so you certainly need a bit of a base understanding of what this is all about. So you have the infrastructure level, then you have the application workloads level. If you look into the infrastructure a little bit more, then there's the nodes which make up the cluster. There is the control plane, which is the thinking or the logic kind of part of this cluster. And the worker nodes is your distributed container daemon where all your applications and containers run. Next to that infrastructure, you then have the application workloads. as things are running in containers, this gives it the possibility to run polyglot environments. So you're not bound to, like, compared to old application server days, you're not bound to a certain framework or programming language. You can do whatever you like. And that, of course, makes it more tricky to look into the things and also make sure to correlate what is happening in between them. Next to that, you then still have the Kubernetes so-called topics. I mean, in order to work with Kubernetes, you should probably know what is a replica set, a pod, service, ingress, deployment, and many more. So this is also something you need to know and how to handle in order to figure out if your workloads are basically behaving the way they should. The API server is one component that gives you access to that. This will also play a significant role later on in one aspect of observability. So this is basically running or hosted on the control plane, only there. So the worker nodes do not have that. And yeah, finally, of course, we don't only want to know what the individual workloads are looking like. We would also like to know, are they connected? Are they talking to each other the way they should be? Are those connections oversaturated? Where do I have latencies? And so on. So all in all, because you have that many aspects, you also have many basically access points of how to get information out of what's running in your cluster. I mean, you can start from an application level. That's like the deepest level where you can go. Around the application is the container. Around the container is the pod, and the pod will be running on a node. So technically speaking, you can start observing on many different kind of endpoints. So you can reach out to the API server, you can collect information from the nodes, go into the pods, or even into the application. And with each different kind of access, you get certain different kind of metrics of your observability. Sorry. In turn, you also pay a different price. I mean, some of the things maybe need that you have to install something or change something in the cluster. Something might need you have to like create additional containers into a pod, or like in the most advanced way, as we have seen just in the presentation before, you basically have to go into the application, rebuild the code, rebuild the container, and so on. So this is kind of what I will try to do today, to bring that a bit into perspective, to say if you want to know this level of information, this is basically how far you need to go. Of course, nobody is really keen on having constant application changes and rebuilds and recontainerization just to get certain kind of metrics out. And I want to try to like make this clear how much you're gonna get for how much you want to pay. Right. So this is just I have put this little observability icon loop here, I don't know what is it in English, to visualize where you can put things in. One of the things we're going to talk about, of course, is multi-container pods to put like the agent or the observability endpoint right into that. And yeah, in the end, it's most likely not gonna mean you need to have all of them. But just to give you an idea what the options are and where you can start and where you can move forward with. Now, the Kubernetes ecosystem has a lot of tools around it. I'm pretty sure most of you have seen this. This is the CNCF landscape. So these are all, I mean, and the interesting thing is it like changes every week and new things are getting added. So this is probably already an outdated screenshot because it's a month old. But in there, they try to categorize what are the various technologies around in around that ecosystem. And the one of particular interest for us is observability and analysis. So even that one is not entirely visualized here. So we have monitoring, we have logging, and further down there's also tracing. You can open it on your own device, and it's probably going to look different already again. So most of the things, or like, are somewhere hidden in that section of the landscape. I will also talk about a few things which are not given in that landscape. Everything I'm going to talk about is purely open source. That's probably an important thing to mention, because of course there are very good commercial solutions for like a holistic kind of observability experience. But this is not what the point I'm trying to make. I'm not want to compare vendors with each other and I give my personal recommendation. It's more like looking into the technologies to understand how far are they at this point, what can they provide, and how can they help you. All right. So Let's start at this kind of entry point level. Basically, the thing you're gonna get when you start with a vanilla Kubernetes. So this is something you can always do without any further extensions to your cluster. Basically, that line right here to use the agent on the API server. So this is probably what you're going to start with when you learn Kubernetes. You learn the kubectl commands. One of them is get. With get, you can query various informations. With describe, you can go a little deeper. With the logs, you can basically grab the logs, which are especially those ones which are exposed on standard error and standard out. And I'm going to talk about kubectl debug and exec a little more. So this is something that everyone can do. Now, if you work on those, just basically on a plain command line, if I just go here and say kubectl get pods, and I use basically the pods of like all namespaces, you can already see that you're certainly going to get to some limitations. So this is not like a super busy cluster, but in the end, your CLI will have a restriction to visualize things in a way that you still can comprehend it. There are also tools. Sandra Parsik has shown quite a few good ones this morning in her Kubernetes survival toolkit kind of talk, which I like very much. So some of them are based on the CLI itself, so you don't need any additional tools. The other ones are basically based on a browser, so you don't need to install anything. You can just like use your browser. And there are even fat clients for probably the best UX, but still most overhead when installing them. So when I started giving this talk a while ago, I was using the tools Octant from VMware, Scope from Weaveworks, Lens, and K8s. Now, in the meantime, things have changed a little bit. So Weaveworks Scope has his last commits on GitHub a couple of years ago, so there's less activity there, to say it this way. Octant, in turn, from VMware was officially deprecated, which I think is a bit of a shame, because I really liked using this tool. Lens has gone the direction of becoming more commercial, depending on how much, like how long and how much you're going to observe and how big your company size is and all that. There is an open version to it, but still, this is the direction how things went. Except K8s just stayed the way it always was, so I'm definitely using this and like this a lot. There are new kits. Basically, one is called Headlamp, the other one is called Schooner. In the end, it totally doesn't matter, because the point I will try to make is they will look different, but in the end, they will all give you the same kind of information. So this is a screenshot from K8s. I can also show this live if the network is friendly here. This morning, it didn't work so well. So in the end, you have a command line tool where you can go in and say, I want to see all the various pods. So you also got a visual highlighting if some of the things do not work as well. So this is like an initial indication where you can start. And from there on, you can jump in and say, okay, maybe I want to get more details, or I want to grab the logs. And so you can see that the logs of past and basically cut it down to certain timestamps. Or you can jump out of that again and say, I want to execute a shell, and then jump into a shell of that of the container in the pod and start doing your things from there. So as I said, this is basically something that everyone gets for free. You don't need to put any changes onto your Kubernetes cluster to get there. This is a screenshot, for example, how Octant looked like. So this is like a web browser. This is, of course, helpful, especially for people beginning to use the tools, because you have this kind of nice grouping here. So which objects belong under the category of workloads, what are services, what is config and storage, and so on. And you get it all nicely grouped and so on. This is the same thing in green, so to say, how Lens looked like. So in the end, the functional difference of those tools wasn't very big, because they were, of course, all limited to what the Kubernetes API provides. I can, for example, quickly show another tool. So let's try Headlamp this time. I showed Schooner last time. So they are basically tools that you can run within a Kubernetes cluster, like as a standard deployment. So let me just jump in here. And so this is going to ask me for a token now that I copy out. Authenticate. And so I have a similar thing here. So I see the objects in my cluster. I can go into the workload, into storage, and so on. And it's of course a quicker navigation and compared to typing kubectl, do this and that all the time. So the same things you're going to get here. So you can go into the pods. If you select the pod, then you have the options to either look at the logs, check the timestamps, or open a shell, which is particularly nice if you can do that in a browser, so you don't need any additional toolings, and you can start looking at things from there. So with that, you can already start to get a fundamental understanding of how well things in your cluster are. Now, kubectl debug is something which is fairly new. I think it was only introduced in Kubernetes 1.23. So who's been using kubectl debug? 2 hands. Right, I know 1 hand, because this is my colleague Paul that actually brought me to the idea of checking it out. With the situation that, let's say, we have the question he asked me initially, so we have this Java application running, and what he would really like to do is to run htop in that container. But of course, htop is not like the standard tooling that you would get installed in a certain container, so you couldn't actually use it. This problem gets even worse if you have like a distroless image. So I have one distroless image here. So for those who are not familiar with this, it's basically an image that doesn't have a Linux distribution underneath. So it has only the things to execute the process, but it has no shell, it has no nothing. So this is my distroless image. And normally, if I want to debug an image, I would, for example, go into K9s. And you see it's K9s, not K8s. This is the one. And if I say open up a shell now, it's going to come back. It's not going to work. Or in the worst case, it might get stuck and then come back. So if in a normal case, I would say, OK, I will try this myself and say kubectl exec. And I want to have a shell in that container. And it says, OK, there is no bin bash. And there is basically nothing in there. There is no other shell. There is not even like, I couldn't even call like an ls or pwd command because they're not there. So with that debug command, I can say kubectl debug. Then I specify my pod. And then I basically attach an additional image. So this is an image that I built, where I put all my universal toolings in there. And I have to specify the target container name. So if I do that, I suddenly have a shell, and I have root access in the container because like the shell binaries and all the other binaries were provided by that additional image. So to have a bit of a look in there, it basically puts that debug container into the same namespace as the application container. So this is different from like a sidecar concept where you have like 2 separate containers. This is basically using the same Linux namespace to connect. And then once you're in there, I could fulfill Paul's wish and say, now we have htop, and you can check all the threads in your container live. And you can, of course, do all various other things. So this is like if I press tab, then I have like 600 whatever possibilities of toolings. And in particular, I put network toolings in there where I can scan if the connections are working fine and so on. So this also doesn't require a restart of the container or nothing. It just gets attached live. It's probably not so safe looking at it from a security perspective, but it's like, yeah, very powerful for what it's supposed to do, like debugging. All right, so to summarize this entry level, the characteristics is like, yeah, you don't need to change anything in the cluster. It's completely non-intrusive. It helps for your understanding, but the limitation at this point is you don't have any network insights. So you would see how the individual applications are behaving, or if they throw errors in the logs or whatsoever. But you wouldn't see this application is supposed to connect to that one, and this connection is not happening unless you get errors in the logs for that. So that's kind of where it ends. To address that, there's the concept of service meshes that most of you will probably have heard of. However, in the meantime, there have new ways emerged of how to do service meshes. The initial idea of doing a service mesh was that sidecar pattern I was just trying to refer to. So basically, you use the pod, and within the pod, you start a second container. and not in the same namespace, so they're completely isolated containers. And normally people would think, if you hear service mesh, observability is probably not the first thing that would come to your mind. Because with service mesh, you always do like advanced traffic shaping, things like circuit breaking, retries, blue-green deployments, canary rollouts, or encryption of the traffic. But there's this technology, Cilium, that brought out a beta of a service mesh, which is now not beta anymore. Now it's like a fully released. But when they started with it, they did a survey and asked the people, what are the features in a service mesh that interests you most? And by big surprise, observability was actually the must-have factor #1 that most of the people answered. So obviously, people do use service meshes for the purpose of observability. Now, who is familiar with the concept of service meshes? Half of the hands. Okay, so I'm going to explain a bit. You all, as you raised your hands before, I would expect to know what a pod is, and there's an application container in that. And this is connected to like the Kubernetes network, so Kubernetes can make the things talk. But Kubernetes also allows this concept of adding additional containers to a pod, potentially as many as you like, but they have limitations. So they would always have to be scheduled on one certain node. They share the same file system. They share the same network address. And they always have to be scaled up and down with each other all the time at the same point. So you shouldn't basically try to put multiple application containers into one pod. But due to the fact that they share the same network, it makes a lot of sense to put like a proxy container in there. So because then this proxy container would see all the network traffic that goes through your app, which makes it like a perfect monitoring agent because it will just see everything. Now, this doesn't make so much sense if you just put it into one app, but if you put this into all of your apps across the board and then aggregate that data, you get a certain good understanding of what is the traffic flow between all my components in that cluster. And the additional advantage is this is totally independent of the language because it doesn't go into the application container. So you could have like Vue.js, Spring Boot, whatever, Java, Go, basically anything. Anything that runs in a container can be accompanied with that sidecar, which is basically only collecting the network metrics. The other advantage is you don't need to rebuild or even touch the container. So you can just like basically add it, and if it's not your thing, you can throw it out again. It will not really harm your cluster a lot. The only thing is when you add a sidecar or a second container, you will have to accept one restart of the pod. This is something that will eventually happen. All right. And with that, you will suddenly have a lot better insight of what's happening like within your traffic flow. So you can see what's coming in from the ingress, which components are being traversed. So right here, I did a split of doing 2 different versions of an application. So I could see what is like the traffic distribution there. Like service meshes would also allow me to control that distribution. I could also see the response times between the individual components. So this would certainly help me on a level of isolating problems. So when we saw Kube API, would maybe be a thing to say, I sense problems. I know that there's something wrong. This one could help me to say, okay, I could pin it down to certain components. So these are the poor performers, and these are things where things might be going wrong. I mean, for such an application, you probably don't need a service mesh. But if your applications tend to get bigger, they would also help you to visualize, to say, is actually my traffic flowing in the way I want it to? Are the right components speaking with each other? What is the percentage of the distribution? And so on. So this can actually be very helpful. Now, if that is so great, why is not everyone doing it? The problem with that is that you have seen before that you put like an agent or a proxy, whatever you call it, into every pod. And that basically means if you scale up, it's not by application, it's by instance. So these pods will be everywhere. So you get a natural overhead of CPU and memory. But not just that, you also get the overhead, and this is when it turns bad, in network latency. Because when before application was talking to application A to B, now A is talking to proxy, proxy is talking to proxy, and then proxy is talking to B. So you got more network hops that your packets have to traverse and actually to get between the points. Now, I wouldn't get too hung up on which percentile you're going to get it and how bad it is, but you will feel it. my recommendation is try it out. You can easily switch it off again. Now, to summarize this, the traditional service meshes would extend Kubernetes for that lag that it has out of the box to have insights on what's going on in the network. So you suddenly can see and control what's going on in there. You inject those proxies. You still don't get application level metrics, but you also don't need to change anything on the application side. You can change those configuration right at runtime. Now, let me check the time. Okay, gotta run a little bit. The next level, or a fairly new form, which goes in the same direction, is implementing that service mesh in a node-based way. The underlying technology, which makes it pretty popular, is called eBPF. Has anybody heard of eBPF? A few? Yeah. So yeah, it's been around for a while. It only got popular, I think, the last 1 or 2 years. In the last KubeCons, this was a pretty big thing. And the technology goes back quite a bit. So it actually stands for Extended Berkeley Packet Filter, which in the first place, or even in second thought, would probably not make you think of observability. It's more a low-level network thing. It's actually a more low-level Linux thing. So most of you will probably know that in Linux there is a kernel space, which is very protected and secure and doesn't have a lot of changes. And there's the user space where you install all your things and can do whatever you like. Now, in order to get down to these kernel events, you need to get somehow into that kernel. And there is this concept of the eBPF sandbox, which you can imagine of like JavaScript in a web page. So you can add additional functionality to the kernel without being potentially hazardous to the kernel. In the same way that a JavaScript in a web page could never break out and get into your host system. At least it shouldn't. And then you can query those events, and network events are kernel events, so you can then forward it to the user space to process it further. Now, why is that so interesting for us? Going back to that Kubernetes infrastructure, we have those worker nodes where like the operating system, the container daemon, and all the Kubernetes objects are running. This operating system happens to be very often a Linux operating system. So that means this eBPF technology can be applied right there. So that means to create something like a service mesh, you don't have to inject and modify everything on the pod side. You can do these changes one time on the node side. So you basically run components that are able to execute that eBPF code on the nodes and then collect it and send it to a control plane. So this way is the same as in traditional service meshes. It's just the placement of the agent is entirely different. And also, along with that, the latency is different because now all the packets are basically intercepted on a node level and you don't have all these proxies in between. I mean, you have as many proxies as you have nodes. So unless your Kubernetes cluster doesn't have more nodes than pods, and if you do have, I would certainly challenge this design, then you're probably going to be better off with that. So one technology underneath using that and making it very popular is that Cilium technology that I mentioned before. This is a component that sits on top. It's called the Hubble UI. This is all open source, and it works really nice. So you basically, I can try to show. So this is my cluster, and I can see all the namespaces in here. So I have, for example, again, the Spring Pet Clinic. There is no load on this one at the moment, so that's why certain connections are missing. I also have the Open Telemetry demo workshop. This is constantly getting load. So then you would basically see all the connection, who is talking to whom. In this graph, compared to what we've seen with Istio and Kiali before, you don't see the timestamps. You don't see the response times. But there is a way to basically export this to Grafana and visualize it there. This is just something I haven't set up yet. But technically, you're getting the same information as you would get with traditional service meshes. All right. So I could actually have a few more minutes, show this one as well. So this is the so-called Kiali console, which is like sitting on top of the Istio service mesh. And you have that graph view right there. So this is, for example, the graph view of that Open Telemetry demo. And you see you have to basically zoom in and then you can see who is connected. You can also make this more attractive by enabling the traffic animation. So now you should basically see some packets flowing in there. Oh, no, now here they are. That's basically why people really use it, because it looks so nice. And yeah, this is also what kind of Grace showed before in her demo about like the open telemetry, the architecture. So basically, you can have very different services from very different kind of technologies. Everything will flow through the open telemetry OTel collector, and from there you can export it to other endpoints like Jaeger or Grafana Tempo or whatsoever. All right. So that's that. Going back and say, okay. In this case, we inject the proxy on the node instead of the pods. You have this low-level functionality of Linux leveraged for like Kubernetes, for Kubernetes things. Early stage of development is probably not true anymore. I should probably say early stage of popularity, because these tools are like definitely production ready now. What I've seen recently that this is also possible if you get like your clusters from major providers like Azure or Amazon, that you can deploy them with this already enabled. So you have it already in your nodes when they're getting rolled out, and then you don't have to maintain it. And in the end, you get this service mesh functionality in a similar way as the traditional ones, with less overhead. Right. So that brings us to the last one. And so this will talk a little bit about open telemetry, but of course, this is probably the most popular one at the moment, but still it stands in for other technologies as well that work in a similar way. So we're now basically on the level of the application. So we say we discovered something is wrong, we isolated and narrow down to the potential root cause, and now I want to look into the application and see what is not going well. In the end, the most common architecture of how those things work, you basically now place your agent into your application container. So that, in kind of a way, will require a reboot, like a recompilation and a recontainerization. It will then basically put into a database, and from there you can visualize it and basically provide it as whatever observability solution. If you go that way, you will probably find out that there are many different solutions to achieve that. Like getting into your applications, collecting logs, collecting traces, collecting all the metrics. And it's going to be hard to make a kind of a decision there. Now, OpenTelemetry is actually a good example, in my opinion, which is kind of contradictory to the evolution of the other Kubernetes projects. So with the other ones, they're just getting more and more, and things is getting added. Like with that tracing kind of thing, there's the same problem. I mean, people need to diagnose and look into the things, but just adding more and different things, people realized we're not going to come to an overall solution. So with OpenTelemetry, and I think this slide was on before, a certain kind of standardization happened. So especially from a vendor perspective, like with this, the vendors don't try to compete on the level of data collection. So as Grace explained before, so there's a standard of how like these metrics look like and which protocol are they being processed, and then they can be forwarded to different kinds of front ends. And this is basically where the vendors can do their thing and say, okay, we can do AI-based recognition of whatsoever, which can be cool, but in the end, the important thing is that on the level of the data collection and how the metrics are being defined, there's a standard now, and that will definitely be beneficial for us as like end users. Now, a few approaches. I mean, how to get there. I mean, in the end, what we want to do is getting the OpenTelemetry kind of code or monitoring behavior into our application. In the previous talk, we saw how this works very well for microprofile. I have a few other examples. So there is a generic Java OpenTelemetry agent, and with this approach right here, I at least came to a point to say I don't need to rebuild my application. I don't need to recompile my jar file, but I have to rebuild the container. So I'm basically in the Docker file. I'm adding I'm downloading basically the OpenTelemetry Java agent, and then I'm going to add this to the Java process. So in this case, my actually application component stays untouched in that way. This will work. However, I have to stick with all the defaults then, and I can't do any modifications by myself. But as I said before, I just want to evaluate which level of intrusiveness do you actually have. This is basically kind of the entry level what you can do. Then, of course, you need to configure it. So what is your application being called, where you're going to want to forward the data to, who is basically the exporter, and so on. So this is a kind of a common standard across that. Of course, you can also go a level deeper and say, now I really want to add this dependency of this agent at build time. So here we see the Maven example for a POM XML, where we, for example, use Sleuth as a monitoring component and add this OpenTelemetry exported there as well. So this is one way how we could get the data. And then again, this is a Spring example. We could, of course, do like the configuration in the application properties file. So this is how it's being processed and then forwarded. Similar things basically exist for all kinds of frameworks. So this is like how you would do that for Quarkus. I'm not sure if I have a Micron example in there, but they have something equivalent here. Right. So what does it give us? Now, if we look, this is a screenshot from Jaeger, which is like a general distributed tracing kind of component. And I should say in this first screenshot, the data is not coming from OpenTelemetry, but from a service mesh. Just to show you that, because in this kind of display, I'm only seeing the outside, like the outside of a span. So basically something going into a component and then leaving it again. So I can see that this component would call this one, but I'm not seeing what's inside of it. And this would certainly change if you add like OpenTelemetry, because now you're going to get into the code. So it's the same outer kind of span, but on the inside, you could now see what are my individual methods doing. For example, here I make the connection to the database, and then I can find out how long is my database call taking, or is that the problem in my application. If this is not enough, then the next level is basically to use that API and change something in the code. So this is like a Kotlin example here, where I say, okay, this is a certain method that I would like to have a deeper look into it. And then I can annotate this in this withSpan method and give it a certain name. And then I can also define a certain span attribute. So to say whenever this method is invoked, I want to make sure this attribute is also locked and becoming part of that trace information. So these are the things which I basically change manually, but then I'm kind of in there very deep because I'm actually have to change the code. In turn, I would also see this. So looking at this trace right here, I now have this product tender.fetch like custom span in there, which wasn't there before. And if I expand it, I'm getting the ID locked. So if I have a certain behavior that generally my calls work fine, but for some kind of parameters, they don't seem to work fine, and it's hard to basically diagnose, you can customize to lock those parameters out and then do a deeper analysis to say, is it actually depending on the values that it's currently processing? All right, so I have to give kudos here. These are two guys the demos that I learned from. Especially Nicolas is going to give a talk tomorrow about exactly that. So he's going to do a deep dive on a talk only about OpenTelemetry, as opposed to mine, which is kind of only putting it into the bigger picture of how you can do observability in general. Right. So we've looked at that. There's something else I want to introduce real quick, because that's something like colleagues of mine have implemented. It's called OpenAPM, which is supposed to help you with your decisions about what to use as, or what you can actually combine in a technical way as observability solutions. So you see there's a long list of agents, libraries, transports, collector, and so on. And this is also the tools that I used to kind of model the diagrams before. So I can say, okay, let's say Grafana. Everyone uses Grafana. Where did it go? So, and now shit. I'm sorry, I shouldn't say that. I'm gonna edit again. Okay, it doesn't like me today. Right, so I didn't want to press this button, but now you can see what are basically the upstream and downstream components. So who are the technologies that could feed into Grafana? And we also have a definition, like a distinction here of what is like a commercial tool and what is only and what is open source tools. So I could, for example, say, yeah, I want then let's say Prometheus server to feed in my Grafana, and then I can say, okay, what do I want to feed into my Prometheus server? There could be micrometer and or potential other things. So this is basically how you could set up and model a landscape and kind of evaluate which tools are playing along. So as this is open source, I mean, everyone can contribute and say, okay, I have a solution, I know how that works. You can add it to that. And if not, it still makes nice diagrams. All right. So yeah, to summarize the application part, I mean, this is something I would probably not recommend to just like put in everywhere, because this goes into the deepest level of monitoring. It goes into your code, and potentially you don't want to like trace all the calls out, because that would kill your performance significantly. But you've seen how you can approach things, like adding it to a container, adding it to your code in general, and then even customize the individual calls in your application. That's, however, the only way how you can enable root cause analysis and go and find the problems that you have right in your code. All right, so that's the summary of things. I mean, as I said before, in the end, there's probably not that single right one that will help you with all your problems. And again, there are probably commercial solutions out there which can combine all those things. But with the tools I've shown you before, you can get a kind of an understanding and expectation and say, I know that this is possible, and I know that this is what I need to have, and then make sure that your commercial solution, in case you want to buy one, really fulfills all of that. All right. Again, this was the link to my deck, if you like it. And with that, I would say thanks a lot for listening. Open this up for question, and if not, we can also go out and have a drink then. Thanks very much.